Selamat sejahtera kepada dokter. So, topik kita adalah electrostatic voltmeter. Kita dari group 1, which consists of me, Tang, Huong, FItzgerald, Atanatasha, Alief, Alwi, and Carlina. So our objective for this topic is to understand the electrostatic voltmeter, also discuss the advantages and disadvantages of it, and also learn their punya construction and working principle, and also explore the uses of electrostatic voltmeter in our daily life and also in circuit. So what is actually an electrostatic voltmeter? So it actually is an instrument which designed to measure the high voltages with very high input impedance. And also it, unlike the conventional voltmeters, we actually rely on current flow through resistive elements. And this electrostatic voltmeter are use electrostatic force to determine the voltage level. And their punya characteristics make them more ideal to measure high voltage in sensitive electronic applications where minimal loading of the circuit is essential. So sana ada gambar which tunjuk how the electrostatic voltmeter look like.
Now let's have a look at the construction of an electrostatic voltmeter. As we can see in figure 2, the components of an electrostatic voltmeter are mounting plate, guard plate, fixed plate, guard hoops or rings, mirror, balance, capacitance divider, dome, and balancing weight. The guard rings, which are denoted with the H letter, is used to maintain uniform electric field between mounting plate and also the fixed plate. And it also prevents corona, which is a luminous audible discharge, and electrostatic field fringing at the edges. And also, due to small capacitance and very large insulation resistance, the input impedance of an electrostatic voltmeter is high. Also, in order to balance the mounting plate, counterweights are added to the R. R is balancing weight, and calibration is made in terms of the counterweights.
We are going to talk about the advantages and also disadvantages of these electrostatic voltmeters. So the advantages is these voltmeters actually have high input impedance, which actually can help minimize the loading effect on the circuit being measured. They also can provide accurate measurements of high voltages and making them suitable for precise applications. And dia pun boleh consume minimal power since they draw negligible current from the circuit. And they do not dissipate energy, which also ideal for measuring in high impedance circuits. As for the disadvantages, there are other limit to high voltage measurements and may not provide accurate readings for low voltages. And the construction might include sensitive components that can be fragile and prone to damage. They also require periodic recalibration to maintain the accuracy as their calibration can drift over time. Next, I'm going to talk about the working principle of electrostatic voltmeter. So the fundamental concept behind this voltmeter is actually based on Coulomb's law, where this law states that the force of attraction or repulsion between two charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. So the formula is given by in the slides. So next is actually this electrostatic voltmeter it measures the voltage by comparing the electrostatic force between the charges against a non-mechanical force. And in the electrostatic voltmeter's fields, the attractive force between the electrodes of a parallel plate capacitor can be calculated by using the formula given. So about the constructions, we can roughly go through. This voltmeter actually consists of two plates, which is one is fixed, one is movable. So when a voltage is applied across these plates, an electrostatic force is generated. So the operation of the voltmeter is like this. When a voltage is applied across the plates, it generates an electrostatic force. So this force will tend to move the movable plates towards the fixed plate. So the movable plate is actually attached to a spring which exerts a mechanical force that resists these movements. So when the movable plates comes to rest, when the electrostatic force and the spring's mechanical force balance each other, and this deflection of the movable plate from its original positions is actually the measure of the applied voltage. We are going to talk about the application of electrostatic voltmeter, which one of it will be the high voltage systems because it is suitable for high voltage systems due to their high input impedance and no power will be drawn and also preventing measurements distortion. Next will be they are applicable in electronics industry because they can use to monitoring and controlling electrostatic charge in manufacturing environments. Lastly will be the laboratory applications, which due to their high accuracy, these voltmeters are preferred for laboratory applications, particularly in physics and also electronics labs.
Alright, electrostatic voltmeter in a circuit. In figure 3, it shows how to use an electrostatic voltmeter to measure voltage on the subject. So, as usual, we take the voltmeter and then we connect the probe and then calibrate it and then we put the probe perpendicular to the surface under the test. And if it detects the voltage, the movable plate will move. Therefore, the voltage is measured. So here is the list of references we used to complete the slide for electrostatic voltmeter. Next, we're going to talk about electrostatic wattmeter. So we have five objectives. The first one, to introduce the wattmeter and explain its fundamental purpose. The second one, to understand the wattmeter application. The third one, to know the correct configuration of wattmeter. The fourth one, to analyze the benefits and limitation of using a wattmeter. And the fifth one, to illustrate how a wattmeter is incorporated into an electrical circuit. So, electrostatic instruments. Usually, electrostatic instruments will consist of two electrodes with different electrical charges. For example, this one is positive and this one is negative. And the quantity which is measured by the electrostatic instrument is converted into either AC or DC voltage. So, what is an electrostatic wattmeter? It is used to measure a small amount of power, practically when the voltage is high and the power factor is low. This type of wattmeter also used to measure dielectric loss of cables on alternating voltage for calibration of wattmeters and energy meters. As you can see, the man holding the instrument that is electrostatic wattmeter. So these are the symbol of wattmeter. The first one is the basic wattmeter circuit symbol with a circle and W in the center of it. And the second one is the electrostatic wattmeter circuit symbol, which is much more complicated than the basic wattmeter symbol.
We are going to talk about the construction of electrostatic wattmeter. So there's actually an example. You can see the figure 1 where it actually consists of four insulated brass quadrants, which is Q1, Q2, and Q1 prime, Q2 prime. And they are cross connected. And also there's a moving vane and also needle. So for the electrostatic wattmeter, is actually using the same basic theory of electrostatic instruments. It actually consists of fixed and movable electrodes, which will generate an electrostatic field when a voltage is applied. And this field will create a force, which causing the movable electrodes to experience torque. This torque is actually proportional to the power being measured. So the movement of the electrodes will translate into a power reading and display on a calibrated scales. These overall components are enclosed in a protective housing.
There are two types of electrostatic wattmeters application. The first one is without amplifier and the second one is with amplifier. So let's look on the first one first. From previous figure, That is the application of electrostatic voltmeter without amplifier. And the potential difference between quadrants Q1 apostrophe Q1 and Q2 apostrophe Q2 is IR, which follows the Ohm's law V equals to IR, and thus proportional to the instantaneous current in the winding of the magnetic specimen. So the potential difference between the needle and quadrants Q2 apostrophe is V volts. This is equal to the instantaneous potential difference across the winding on the specimen, whilst that between the needle and quadrants Q1 apostrophe Q1 is V plus IR volts. Let's say there is a linear torque or torsion relationship for the suspension. The rotation of the needle is thus seen to be proportional to the mean power supplied to the specimen. This includes the winding copper loss plus half the loss in the quadrant resistor R. If we connect the needle to the quadrants Q2 apostrophe, we can measure the latter quantity. This is only applicable if the torque is given by 1 over 2 K I power 2 R. And you can see the formula in that rectangle. Next, application number 2, which is electrostatic voltmeter with amplifiers. When working at the small values of magnetizing force and flux density, the voltage amplifiers is used to supply the needle and quadrant potential difference. And then, if we don't use the amplifiers, we need to increase the value of R to produce an adequate quadrant voltage results in a non-sinusoidal flux waveform, which means the provision of an adequate potential difference V between the quadrants and the needle requires an inconveniently large number of turns in the winding of the two. As we can see in the previous picture, amplifier A and amplifier V is put like this. Therefore, the wattmeter deflection is directly proportional to the mean power supplied to the specimen. With the double winding shown, no winding copper loss is included in the measured power if a single winding is used. However, as shown by the dotted connection, the copper loss in the magnetizing winding is then included in the measurement.
We are going to discuss about the advantages and disadvantages for the electrostatic wattmeter. So for the advantages, it is more precise, free from errors on account of waveforms and frequency and eddy current, and it has more working torque. As for the disadvantages, it will occur small errors due to the friction, and it might not suitable for commercial use. This electrostatic wattmeter is also large in size and not robust. Lastly, our topic will be hot wire emitter. In these slides, we're actually going to introduce hot wire emitter, understand the applications, discuss advantages and disadvantages of the hot wire emitter, and also learn its construction, working principle, and also explore the application of hot wire emitter in the circuit and also in daily life. What is hot wire emitter? So hot wire emitter is actually an electrical instrument which used to measure the AC or DC by exploiting the thermal expansion properties of a wire. It actually unlike traditional electromagnetic emitters, where hot wire emitters, they are boleh measure current based on heating effect of the current flowing through the wire. We are going to talk about the construction of the hot wire emitter. So it actually consists of few parts. So we're going to go through part by parts. So first one will be the hot wire, which is actually a thin wire made of a material with a high temperature coefficient of expansions. So for example, platinum or tungsten. So next will be the supporting frame, which will help to hold the hot wire and allows it to expand freely. So next will be the scale and pointer, which is actually a needle attached to a mechanism that will translate the wire expansion into a readable measurements on a calibrated scales. So next will be the spring. This spring actually provides a restoring force to the hot wire and also ensure it to returns to its original position when there's no current flow. Lastly will be the connecting terminals, where this terminus is for connecting the emitter to the circuit. We are going to talk about the working principle of hot wire emitter. So first we're going to go through its heating effect of the current. When an electric current passes through the hot wire, the electrical resistance of the wire will cause it to heat up due to the Joule heating effect. And next will be the thermal expansions. When the wire is heat up, it will expand. So the amount of expansions is actually depends on the magnitude of the current passing through the wire. And we need to know that the expansion is proportional to the square of the current, which is also proportional to I square R. Next will be the mechanical translation. The expansion of the hot wire is translated into mechanical motion. This is typically achieved using a system of pulleys and springs. So the wire expansions moves a pointer across a calibrated scales. Lastly will be the indication, where the pointer moves over a scales that is calibrated to reflect the current passing through the wire. So the scale is usually nonlinear due to the I-square relationship, but it can actually calibrated to give a direct current reading. We are going to talk about the advantages and disadvantages of this hot wire emitter. So first of all, it can actually measure AC and DC without any adjustments. Next is actually it can work accurately regardless of the frequency of the current and making it more suitable for high frequency measurements. And it is also straightforward for constructions based on the heating effect of the current, which also makes it more easy to understand and also use. Next will be the disadvantages. This emitter actually takes time to respond because it depends on heating and the thermal expansion of the wire, which will slower than the electromagnetic effects. And it also affected by the changes in the surrounding temperature, which might impact its accuracy. This will be best for measuring moderate currents, where high currents can overheat the wire and potentially damage the instruments.
Now let's see the application of a hot wire emitters. The first one is industrial application, where hot wire emitters are used for monitoring and measuring current in electrical equipment and machinery. This ensure that the equipment operates within safe current limits. Second one, electrical testing and calibration, which is they are used in laboratories and testing facilities to calibrate other measuring instruments and for research purposes where precise current measurement is essential. The third one, battery testing, basically to measure the current draw of batteries and ensure that the batteries and their associated circuits function correctly. The fourth one, power supply monitoring, where the power supplies and distribution system, the emitters will help to monitor the current flow to ensure systems are working efficiently and safe. The fifth one, high frequency AC measurement. It is an advantage for hot wire emitters in measuring high frequency AC because traditional electromagnetic emitters can have difficulties with high frequency currents. But hot wire emitters respond well due to the consistent heating effect at different frequencies. The sixth one, measurement of pulsating current. They can measure pulsating currents effectively. This makes them useful in circuits where the current is not steady but varies with time. And the seventh one, fault detection on circuit, where these emitters can help to detect faults in electric circuits by measuring unexpected changes in current that might indicate issues such as short circuits or excessive loads. So this is hot wire emitting circuit where we can see the current to be measured is on the plus sign, and then we have hot wire, silk thread, the scale, the pointer, the spindle, the control spring, and also the tension adjustment on the negative sign. These are the list of reference we use to complete the slide for hot wire emitters. This is the end of the video. To sum it up, we already presented electrostatic voltmeter, electrostatic wattmeter, and hot wire emitters. These three are the tools to measure the voltage, the power, and the current, and all of them are function differently with different principle. So, doctor, thank you very much for listening to our presentation attentively. Thank you from Group 1. Have a great day, sir.